Okay, we're going to go ahead and wrap up Unit 10 today by looking at Section 3. So we're going to start off with these 6 problems. Now, I want you to go ahead and try to match the blue words on the bottom with some of these different things in these boxes. Now, the key thing to look at is really this, or this, or this, or this, or this. Really what's going on between your functions or here. I would anticipate that most of you, when you look at the lower right one, you see a plus sign, you would then probably go ahead and think addition, which would be correct. Or in the lower left one, you see a subtraction sign, that means you're just going to be subtracting your functions. Now, in the bottom center one, that's a fraction bar. Remember, a fraction bar is the same thing as division. Top center one is a dot for our multiplication. Now, the top right and top left have an open circle, which is different than multiplication, a symbol that you're not used to seeing, and that's what's composition of functions. And we're going to be getting into that, so don't be too concerned right now about that. So for the most part, we need to go ahead and do this operation. Now, with what we're seeing here, this notation here is identical into saying g of n plus h of n. It's 2 different ways to write the exact same thing. And so we just have to go ahead and add these together. So we need to take our g, which is the first one, put that down, and then add our last one, which is this. And so I'm going to put that down. And well, at this point, all we'd have to do is just go ahead and combine together like terms. We have 4 of the n's plus 1 of them, so we get 5 n's. And then we have that blue one with the blue or black 4, and that gives us a plus 5. So we're going to do this operation and then combining like terms together if we have any. Now, when we're looking at this here, another way to write this is just by saying f of n times g of n. And so we could just put that down. We know that our f of n right here is just this. Our g of n right here is this, so I can put that down. Well, we just have 2 terms times 2 terms, so we can do our double distribution. We can multiply our first terms together. We can multiply together our outer terms, our last, and we can multiply together the 2 inner terms here. And then we can do our last terms here. And then we can go ahead and add together any like terms. Well, in this case, all of our exponents are different, so we don't have any like terms. We're going to leave it like this. Yes, we could factor it, but that would put it back into parentheses, and we're not trying to write it with parentheses. So here we are dealing with a subtraction sign. So another way to write this is just taking our h of x minus our g of x is another way to write this. So all we have to do is just write that down. We can take our h, which is this. We can take our g, which is this. The important thing is when you're dealing with subtraction that you are pretty much putting the last set in parentheses so that you can distribute through. So we can just bring down the green. Then we have to remember to distribute through that red subtraction sign into our parentheses, and we get this. And then we can go ahead and combine together any like terms that we have. The only like terms we have are the negative 3x and our negative 2x. So negative 3x with another negative 2x is negative 5 of the x's with a plus 5. Looking at the next one here, we have a division sign. So another way to write this then is just take g of an n over an f of an n. And so if we write that out, we'll put down our fraction bar. We'll take our g, which is this here. We'll take our f, which is this here. Now, sometimes once you do this, you're not able to simplify fractions. But this just goes back to chapter 8. To be able to simplify fractions, you need to have the top factored and you need to have the bottom factored. So I'm going to go ahead and factor the top. Now, when you look at the top, you can pull out a 2. And the bottom happens to be differences of squares. You will notice you have an n plus 1 on top and an n plus 1 on the bottom. Then you can just go ahead and write what's left. We're left with a 2 on top, and we're left with an n minus 1 on the bottom, and that would be it. Now, here we're going to look at composition of functions. For the most part, you're putting one function into another function. Now, for me, I typically prefer this notation instead. It makes more sense to me. But whether you look at the highlighted yellow or the highlighted green, it's really doing the exact same thing. So what we have here is in the form of the green. I'm going to rewrite it in terms of the yellow stuff. So that's f, and then I need to go ahead and plug in g. Now, when I look at f up here, f just basically says 2 times my input minus 1. What am I plugging into f? Well, that's just this right here, which is g of h, or g of n. So I'm going to go ahead and actually plug in what g of n is. G of n is this here, so I'm going to take that and plug it in. And then we just have to simplify this. So I can go ahead and distribute through. I get 2n squared plus 2 times 4, which is 8, with a minus 1. Well, my 8 and minus 1 can go together. I get 2n squared plus 7, and that's all I would get. That's compositions of functions. Basically, you're taking the second function right here, and it goes in as your input into the first function. So you're working from the right to the left. Now, over here, I'm going to go ahead and rewrite this as an h with my input, with this, which I'm putting into it. Basically, I'm putting h into itself. So I'm going to put down what the red is. Now, the red says 2 times my input minus 4. But I'm putting in h of n. So when I plug in that, once again, I need to take h, which is this, plug it in, and then all I have to do now is just go ahead and distribute through, combine like terms, and I get 4n minus 12. That's composition of functions. You take the function on the right and plug it into the function on the left. So now we're going to go ahead and look at inverses. For inverses, we need to, first of all, it says to graph the function and its inverse, but we also need to find the inverse. We'll find the inverse first, and then we'll end up graphing both of these. So to find your inverse, now what we have right here is identical to y is equal to a negative 4x plus 20 over 7. So remember, f of x and y are the exact same thing. So to find your inverse, you need to switch x and y. And then all we have to do is go ahead and solve it for y. So we got to get y by itself. Well, to do that, we'd have to get rid of that over 7. So we'd have to, which is dividing by 7. So I'm going to multiply both sides by 7. Then I got to continue to get y by itself. So I'm going to go ahead and subtract the 20 from both sides. And then I need to go ahead and get rid of that timesing by negative 4. So I'm going to divide by negative 4. And so then I get minus 7x minus 20. I don't know why I put minus 7x. It's a positive 7x over our negative 4 is equal to our y. Now, when you're dealing with inverses, we're going to write this in inverse notation. We had an f of x before, so we're going to write f with a little negative 1 exponent of x, and then I'm going to write out what I had right here. And then all we have to do is just go ahead and graph each one of these. Now, to graph my original function right here, I'm going to go ahead and go y equals, because remember y is the same thing as f of x. I'm going to put each one of my terms on top. Remember, terms are those things that are added or subtracted together over my denominator. Now, that can often go ahead and allow us to use the idea of our slope and our y-intercept. Our y-intercept is 20 over 7, which, as a decimal, is just a little bit under 3. And then I have to look at my slope, negative 4 over 7. So down 4 and over 7. And then I need to go ahead and draw in a line going between those 2 points. And I'm going to label this as f of x. Now I'm going to do the same thing down here for my inverse, which is once again is y is equal to, it'd be negative 7 over 4x, and then negative 20 over negative 4 is a plus 5. So for my inverse, and I don't know why I have that 50 there, it's just plus 5, I'm going to go up 5 for my y-intercept, and then I'm going to do my slope, which is down 7, right 4. Down 7, right 4. And then I need to go ahead and draw in my line connecting these points. And then I'm going to label this as my inverse. So that's what you have to do to be able to graph this stuff. Now, once again, if you are trying to find your inverse, you need to switch x and y. Then you need to solve that for y. And then your function notation is written like this, if you had an f of x. Now, if you were just dealing with ordered pairs, to find your inverse for ordered pairs, you just switch the x and the y coordinates. Now, one other thing you need to be aware of is you can go ahead and see if things are inverses or not by taking one function, plugging it into the other to see if everything cancels out except for your variable. So we're going to basically do that composition of functions. We're going to take this and plug it in right here to see if it works. Well, our original function is this. And we're going to go ahead and plug that other in, the 2n minus 4. And we're going to see if this just simplifies down to our normal variable of n. If it does, they are inverses. If it doesn't, they're not. So we're going to go ahead and distribute through. Does not simplify down to inverses, so these are not, or does not simplify down to n, so these are not inverses. Now, we need to try to do that same thing over here on the right. We need to take one function and plug it into the other. So we're going to take this and try to plug it in right here. So our top function says input minus 4 divided by 4. Plug our bottom function in for our x up there, and we need to simplify this down. You will notice on the top, your green plus 4 and your black minus 4, they cancel each other out. And that leaves you then with a 4x over 4, and you know 4x over 4, the 4's cancel and we get x. So we can say yes, they are inverses because it just simplifies down to our nice normal variable with nothing else. If it doesn't simplify down to your nice normal variable with nothing else, you can't have any numbers in front, you can't have anything added or subtracted to it. If it just is your normal variable, then they are inverses.